This question is from Pure Book 1, Exercise 6A, Question 8. With a question like this, you really need to go straight to doing a diagram. It doesn't need to be a particularly accurate diagram, but it will give you a good idea of what you need to do. There are complicated algebraic ways to do it, but if you just use a diagram, you'll find it is actually a very simple question. I'm going to do a similar but different question. So what I'd suggest you do is, after you've watched how I do it, have a go with this question, and at the end of the video I will make sure that the answer is shown. I'm going to start with GeoGebra just so you can see what it would look like on there, and then I'll go through how I do it in an exam. So for my version of the question, I'm going to use a center of 4, 2, and I'll use f as being at 6 minus 4. Use the circle tool, circle with center through a point. Just pick that one and that. Okay, I'm now going to use the line tool to draw the straight line through it. Picking that point and that point. And that's all I need to do. And now I can see where the line intersects the circle at the other side. We can see it's up there, exactly there. So it's at 2, 8. But let's see how we actually could find that. As I say, essentially we're only going to be doing some adding. That's all you'll have to do. So do start with a diagram. I've used a compass, but you don't need one. Just do a quick rough circle. It really doesn't matter as long as you get a basic feel for the geometry of what's happening. So I've got my center there at 4, 2, and I've got f at 6 minus 4, and I'm simply going to then draw the line through by hand from f through c and see where it ends up. So my diagram is ending up here, which, if you remember what GeoGebra told me, that isn't particularly accurate, but it gives me an idea because I'm not going to read the coordinates off there. What I see is I've now got this straight line, and I realize that this length here, the radius, is the same as this length here, again another radius. And in fact, I can also say that the gradient is the same, and therefore I can actually sketch in how I would reach that if I went down and then across. So we can see that to get from F to C, I go across and then I go up, and I'm going to go across by minus 2, and I'm going to go up by 6 in this case. Well, I'm going to be doing exactly the same thing. It's a straight line, and so I'm going to go across again by minus 2, and then I'm going to go up by 6 to get to there. So let's just sketch that in. So I can actually calculate the point at which I'm intersecting the circle again simply by subtracting 2 from the x coordinate and adding 6 to the y coordinate. Now, if I was doing this for a real question, I wouldn't bother writing the minus 2 and plus 6 steps in. So we can now just write down the coordinates of G. To check that, you could go through all the palaver of calculating various things, but the simplest thing to do is to notice that the coordinates separately are in arithmetic sequence. So the x coordinate is 2, 4, 6, and that's what you'd expect. It's a straight line, and you know that the distance traveled between the outside of the circle and the center is the same in both cases, and therefore the distance down and across will be the same. Key points therefore for this one are that you should draw the diagram. You don't need to draw the steps in, but draw the diagram. Can be a very rough sketch. Doesn't have to be a particularly good circle. As you can see, mine is inaccurate in terms of scale. All you really need to do is just see the properties of what they're talking about. Trying to do that sort of thing in your head is not easy, and certainly there's no reason to do that. And in this case, algebra would give you an answer. You could do all sorts of fooling around to do it, but it is far, far simpler to sketch a diagram and then do a couple of additions. Okay, so the answer to the actual question is going to come up now. So do have a go and then see if you do get that answer.